Very early in its history, McDonnell Douglas firmly established its reputation as a company who could deliver the products that airlines and passengers wanted to fly. The moment the DC-2 was introduced in 1934, it immediately surpassed all previous records for transport performance and set a new standard of air travel comfort. People used words like rugged, durable, and reliable when describing the DC-2, and all the Douglas airplanes that followed it down the flight line. That same level of excellence continues today in the current McDonnell Douglas products. McDonnell Douglas has now delivered over 2,000 twin jets as evidence of their universal acceptance and popularity. The MD-80 continues to maintain the best dispatch reliability in its class and continually ranks tops in passenger preference surveys. With the new MD-11, McDonnell Douglas once again sets a standard for commercial transport excellence and technological innovation. Key design features include a new flight deck that requires only 2 crew members, a number of aerodynamic and technological improvements, and a restyled, flexible interior that can be reconfigured in a matter of hours. Today, we'll look at these and other features that make the MD-11 the most advanced and automated commercial aircraft in the world. The MD-11 is powered by new higher thrust computer-controlled engines, rated in excess of 60,000 pounds of thrust each. McDonnell Douglas currently offers its customers the choice of either General Electric or Pratt & Whitney engines. The engines are individually regulated by a full authority digital engine control unit, or FADEC, which increases efficiency, lowers fuel consumption, and reduces pilot workload by controlling engine performance. The MD-11's advanced technology horizontal stabilizer also features a number of improvements that contribute to the tri-jet's increased efficiency and lower fuel consumption. The tail is smaller and lighter than the one on the DC-10 to reduce weight and drag and improve cruise performance. It incorporates a 2,000-gallon fuel tank, which not only increases fuel capacity, but also enables the center of gravity to be maintained further aft than in the DC-10. In addition, it features a leading-edge anti-icing capability. McDonnell Douglas also extended the MD-11 tail cone to reduce afterbody drag. Yet another improvement in the MD-11 is the use of carbon composite brakes, which represent the most significant advancement in brake technology in 4 decades. The new brakes provide shorter stopping distances, longer brake life, and a weight savings in excess of 2,000 pounds in comparison to steel brakes. In addition, the landing gear has a fully automated anti-skid and automatic braking system as standard equipment. During certification, the MD-11 became the first commercial transport to demonstrate a maximum speed takeoff abort with 95% worn brakes. One of the most distinctive of all MD-11 features is the 8 3/4-foot winglet, which extends both above and below the horizontal wing surface. The winglet is aerodynamically designed to improve the aircraft's efficiency, range, and speed. This is a thoroughly proven design based on extensive wind tunnel and flight test development programs. The winglet, along with the many other technological advancements of the MD-11, make the tri-jet unique among today's wide bodies. Equally unique is the restyled passenger cabin. In designing the MD-11 interior, McDonnell Douglas worked with a number of airlines to make sure that the cabin would be comfortable and convenient for both passengers and crew. The MD-11 seats a maximum of 399 passengers in all economy, or 293 passengers in a 3-class configuration. The MD-11 fuselage design can accommodate 6 abreast seating in first class. An optional business class is available with 7 abreast seating. Nine abreast seating is the typical economy class arrangement. All seating configurations provide wider aisles and more headroom than in comparable wide bodies. Entertainment features include optional armrest video monitors in first class. Aisle video monitors are located throughout the cabin. Larger screens are located in front of each section. Overhead stowage compartments are 3 times as large as another aircraft. They also feature built-in handrails to assist passengers and crew members. The galleys are located in 3 complexes to provide efficient beverage and meal preparation. Either 2 or 3 galleys are in the first-class cabin. 2 galleys are provided in the mid-cabin section. 3 large capacity galleys are aft of the economy class cabin. The lavatories incorporate many features to assist the handicapped passenger. Doors, door slide latches, toilet flush buttons, and cabin attendant call buttons are all enlarged for easier use. Also added is a handrail and a single push action faucet with automatic shutoff. The MD-11 offers 2 crew rest options. One is a sky bunk with 2 individual sleeping quarters located in an aft galley area. A telescoping bunk which can be entered from the cockpit without going through the passenger compartment is provided for the crew. In a number of recent surveys, the MD-11 achieved a very high comfort score with passengers. Pilots are equally pleased with the aircraft. A brief look around the flight deck will show why. The MD-11 flight deck uses advanced technology to give the pilot superior control of the aircraft systems and flight path. What you see is a result of a joint effort between McDonnell Douglas and many of the world's leading airlines. These efforts produced a flight deck that is the ultimate in cockpit automation, workload reduction, and efficiency. The high level of automation allows the MD-11 to be operated by a 2-pilot flight crew. The duties and procedures performed by the flight engineer on the DC-10 are now performed automatically by the MD-11's aircraft systems controllers, thereby significantly reducing pilot workload. For example, on the DC-10, there are 28 switch actions required to jettison fuel. The same procedure takes 1 pilot action on the MD-11. MD-11 system faults are corrected automatically without manual intervention. This gives MD-11 pilots unprecedented freedom to just fly the aircraft, instead of spending time analyzing problems and taking appropriate actions. But the crew still retains full authority to make manual inputs, and the pilot's decision is never overridden by the computers. Flight deck features include a fully integrated dual flight management system, triple inertial reference system, full-time, full authority auto throttle system, automatic thrust mode selection, auto flight system with single or dual automatic landing capability, automatic center of gravity control, automatic system controllers, automatic stability augmentation system, wind shear detection and guidance system, traffic alert and collision avoidance system, and an electronic instrument display system. The MD-11 features a glass cockpit that offers all essential flight data at a glance on 6 CRT displays. From left to right are the captain's primary flight display, navigation, engine and alert, systems display, first officer navigation, and the first officer primary flight display. The CRTs replace the traditional instruments, give the pilot more information, and eliminate the need to review the overhead panels. The primary flight display is arranged in the basic T configuration and contains the airspeed indicator, attitude indicator, flight director command bars, altimeter, and vertical speed indicator. The heading indicator is located on the bottom, and the flight mode annunciators are on the top. Other features integrated into the display include altimeter barometric settings, radio altimeter display, taxi speed, flap slat position, approach minimum altimeter settings, airspeed bugs, instrument comparator information, and localizer and glide slope indications. Approach and landing information includes ILS deviation, marker beacon, and approach minimums. Thrust, roll and pitch modes, which are displayed in the flight mode annunciators, are auto flight, FMS, and landing mode selections. The navigation display combines the functions of weather radar, map, plan, VOR, and approach modes. The modes are selected from the electronic instrument system control panel located on the glare shield. The MD-11's dual flight management system provides worldwide navigation database information for flight planning and performance computations. Two multifunction control and display units located on the forward pedestal area are the primary interfaces for the flight management system. Flight management system data is always available to the crew whether or not the FMS mode is selected, and the crew can always modify the FMS profile. Flying the optimum computed thrust, nav, and pitch profiles will achieve optimum fuel savings for a prescribed route of flight. A consistent set of colors is used so the pilot can easily recognize whether FMS data or manually selected data from the auto flight system is being flown. Selected speed and pitch modes are displayed in the flight mode annunciator. When the color is magenta, the modes are either controlled by the flight management system or are equal to the FMS values. White indicates a crew-selected value. The flight control panel is centrally located on the glare shield. Here, the crew can select the thrust, roll, and pitch modes for FMS-coupled operation, or manually select any mode as required. The manual selection knob allows the pilots to pre-select speed, heading, and altitude. Pulling the knob activates the selection. FMS modes are activated by pushing the FMS speed, nav, or profile buttons. Pushing the auto flight button selects auto throttles and autopilot modes. Landing modes are selected by pushing the approach land button. The system then automatically provides the highest land mode available. These include dual land, single land, and approach only. This screen shows both engine and alert status. The engine displays are traditional and include selected thrust limits and ignition on displays. The lower portion is dedicated to alerts information. The MD-11's unique alerting system requires minimal crew interaction with the overhead systems panels. The display provides all information about faults and their consequences. Overhead annunciators are used only to help locate a specific switch or light during manual operation. A level 0 alert is shown in the lower right-hand column of the alert area. These alerts indicate operational or aircraft system status information, such as engine anti-ice on, or automatic actions such as 1-3 ISIL valve open. A level 1 alert is shown in the top left column of the alert area and requires only pilot awareness but no action. These alerts are normally a result of a fault detected by the automatic system controller and tell the pilot what action has been taken. The master caution light warns the crew of a level 2 alert. A level 2 alert is displayed in the top left column. The box enclosing the message indicates that pilot action or crew awareness is required. The master warning light alerts the crew to a level 3 alert. A level 3 alert appears in the top left column of the alert area. The alert is enclosed in a red box and preceded by a solid triangle to distinguish it from other boxed alerts. A level 3 alert requires pilot action. The systems display shows the status of the 4 major systems in schematic form, plus additional aircraft information. The displays are selectable at any time from the systems control panel located just aft of the throttle quadrant on the pedestal. Selections include the hydraulic, electrical, air, and fuel synoptic pages. The configuration, miscellaneous, status, and consequence pages. The associated system Q switch illuminates during a level 1, 2, or 3 alert to identify the affected system display. The secondary engine display is the default display and appears when electrical power is initially applied to the aircraft. This display shows gross weight, fuel, center of gravity, stabilizer trim, cabin altitude, cabin rate, oil pressure, oil temperature,
and quantity, and APU parameters when operating. The system's experience gained from 17 years of DC-10 operation was used during the design of the MD-11 to automate system operation and reduce crew workload. All functions from pre-flight to termination require little input from the crew. The aircraft systems controllers monitor all MD-11 systems for proper operation. In most cases, system reconfiguration resulting from a malfunction is automated. Manual input is required for irreversible actions such as fuel dump, fire agent discharge, or integrated drive generator disconnect. During normal operations, when the cockpit is configured for flight, all annunciators on the overhead panel are extinguished. The dark cockpit immediately confirms to the crew that the overhead panels are correctly configured and that no abnormalities exist. The MD-11 aircraft systems can be manually controlled from the overhead area of the cockpit. The center portion of the overhead panel contains the primary aircraft systems panels, which include hydraulic, electrical, air, and fuel systems. These are easily accessible from both flight crew positions. The left third of each aircraft system panel controls the number 1 system. The center portion controls the number 2 system. The right side controls the number 3 system. For quick reference, each set of controls is lined up directly with the number 1, 2, and 3 engine fire handles. The panels used the most are located in the lower forward area of the overhead. The panels used less often are in the upper aft area. Each aircraft system panel has a pictorial schematic of that system on the light plate. The schematic symbolically connects the various components and controls on that panel and closely resembles the system synoptic shown on the system's display. The overall design of the primary systems provide the maximum level of operation and safety while allowing the crew full authority to make manual inputs. The pilot's authority is never overridden by the computers.
The MD-11 design heralds the era of the pilot once more being able to concentrate on flying the aircraft, while the automation ensures the most serviceable systems possible are available.
The MD-11 epitomizes the tradition of excellence sustained by McDonnell Douglas through more than 60 years of design and manufacture of commercial aircraft. The MD-11 will carry on the reputation for ruggedness, reliability, and operational economy established by the thousands of aircraft built by McDonnell Douglas.